All right, here comes a fun lesson for today. We're going to get back to actually solving log equations. So we actually have a goal to what we're doing, but we're going to start using some of the properties we've learned over the last few days. Let's get right to it. Let me show you an example here. So first off, I think it should make us all a little happier that we have a goal here again. Our goal is to find x right here. Okay, so we're no longer are we worried about, did I finish the problem, did I write it the way I'm supposed to, find the answer to that problem. Okay. Now we're going to do that today by using, like in this example, we have two logs being subtracted. We're going to go ahead and combine those to one log. And good things will happen from there. So, at first, as far as how do you do these problems, you just kind of do what you've learned. You see two logs, they're subtracted, so let's see what happens if we combine them to one log. So step one is going to be log base 7 of x over 3 equals 1. So I just did the rule for this, turned it into this. Whenever this is subtracted, it's that over that as one log now. And now we're just going back to solving our basic log equations, where if there's only one log in the equation now, which there is, then we just use the rule of log, that this to the power of this equals this. And that'll get rid of logs and hopefully get us on our way to solving. So we're going to have 7 to the first power equals x over 3. Or just 7 equals x over 3. And then, of course, to solve for x, we're just going to multiply both sides by 3, cross that out, 3, we get x equals 21. Let's get in the habit, there's no problem on this one, but get in the habit of checking to make sure that this value that you get, if you plug it back in here, it does not cause a negative number to happen. And in this case, it doesn't. I don't think you need to check any more than that. We're good to go. So put a box around it, move on. Pretty simple problem. Next one, very similar, only now we see addition in between here. We're going to go ahead and combine these two to one log. So we're going to get log base 6 of 9 times x plus 2 equals 2. So that's just using the properties we've been working on the last few days, that this whole thing right here became this thing right here. And just like the last problem, we're just going to use, we have one log in the problem now, right here, and we're going to use the rule of log, that this to the power of this equals this. So we get 6 squared equals 9 times x plus 2. 36 equals 9x plus 18. Did a couple things at once there. Did squared this, distributed here. I'm going to subtract 18. So 36 minus 18 is 18. And then divide by 9. Pretty simple. You can do it. And there's our answer there. Once again, just that quick double check. If I put a 2 in right there, it's positive 4, no problems at all. Here's the next one. It's going to be a little different. I tried to give us some variety here. Still going to handle this like I did the last one. I'm going to take this thing right here. It's got a minus in between it, so we're going to do a division problem. So it's going to be log base 6 of x squared minus 9 over 4 equals log base 6 of 4. Giving you a second to kind of look at that, make sure that makes sense to you. You can obviously pause it yourself as well. But I took that, turned it into this. What makes this one a little different, not harder, just a little different, is we actually have log on both sides now, and we go back to the other type of basic log equations we solved. When we have a log on both sides, then it's really just that this right here has to equal this. So x squared minus 9 over 4 equals 4. No more logs. Now we have a fraction here equal to a fraction here. Think of it like this. So why don't we just cross multiply here? Okay, so we're going to get x squared minus 9 equals 16. We're going to get x squared equals 25. And then we're going to square root both sides. Whenever we square root, we need plus or minus. So it's plus or minus 5. So two answers there. We got positive 5, negative 5. Once again, we should check it. If I plug a positive 5 up in for x here, I get positive 25 minus 9, which is a positive value for the log. If I put a negative 5 in here, I get negative 5 times negative 5, which is also positive 25 minus 9. So we still get a positive log situation. So both answers are good. There's no problem there. There it is right there. One more. It gets a little bit messier, but it's about same idea as the last problem. We have subtraction again here, so we're going to take this divided by this into one log. By the way, before I go on here, I just want to let you know that this is the way to do these problems. Even you might think to yourself, well, what if I just want to cross out all these logs? You can't do that. You can only, if you go back to the last problem, you'll realize if you have log on one side equals log on the other side, then you can say that. But you can't just go around just crossing out every log you see. Okay, we have to have it to where it's log equals log. So we're going to do that right now. We're going to combine the left side here to log base 5 of x squared minus 10 over 7 equals log base 5 of 10. This is actually, it's very similar to the last one. Maybe didn't need to do an extra one, but I think we might see something a little bit weird in this one. All right, so now we're back to, we have the log of something equals the log of something. That's when we can ignore the logs and just say that this equals this. We cannot do that up here when there's 3 of them. It would not work out. So we get x squared minus 10 over 7 equals 10. That's x squared minus 10 equals 70. I'm just multiplying right there. Then I'm going to add 10. So I'm going to get x squared equals 80. And then I'm going to square root both sides. So I get x equals plus or minus square root of 80. But we don't, if we have a square root and we can break it down at all, we always do that. We spent tons of time doing that. So 80 is 2 times 2 times 2 times 2 times 5. So we have a pair of 2's and a pair of 2's. They're going to both come out. Final answer, x equals plus or minus 4 root 5. And then the last thing we want to do here is just, once again, kind of like the last one, if you take this, either the plus or the minus of this number, even though it's kind of a messy number, it doesn't really matter. If you took that and plugged it in here to check the answer, it would get squared, and therefore it would be positive right here. And so, for example, before it was 4 root 5, it was the square root of 80. If you put the square root of 80 in here, the square root of 80 squared is 80. The square and the square root cancel each other out. 80 minus 10 is 70. It's a positive value. You're only checking it wherever the x is. You don't have to check it, there's no other spots over here that have x. So you always got to make sure that whatever your answers are, that when you put them back into the x, that it creates a positive value here for the log. And even the negative square root of 80 would do that, because a negative times a negative, when you square it, is positive. So we're good to go. That's it. These problems were actually handpicked right off the homework, so you should find that they're all the key examples that should help you get through the homework here. So we'll be working on that tomorrow in class. So be ready to, help each other out and get through it. Work hard, be nice, see you soon.